Hello everyone. I hope you're all doing well in this amazing day. We are here for a PagerDuty live stream, and we be talking today about Model Context Protocol, or MCP. Let me just introduce myself very quickly. My name is Daniel Afonso. I'm a developer advocate here at PagerDuty, and I'm very excited to be joined today by two amazing folks. So I'm going to bring them here to the stage so they can start chatting with me. So let me just get this part. I'm seeing some folks already on YouTube. Hello, Anna. How are you doing? Hello. So in the meantime, let's invite to the stage Manuel and José. Hello, everyone. How are you
Hello.
doing?
All good? And you?
I'm good.
Doing fine as well. So would you like to introduce yourselves before we start talking about what brought us here today?
Sure. I'm José. I'm a staff software engineer in the AI First group at PagerDuty. And, well,
Also a software engineer at AI First Group. Yeah. Nice to meet you.
Okay, so everyone, we're here today to talk about MCP, Model Context Protocol. So would you like to tell me what exactly is MCP?
well, I can start, Manuel. Interrupt me when you want. So MCP, and I think maybe we have some slides if you want to share just for visual support. MCP is a standard for creating tools for AI agents. A good way to think of it, and an analogy that's been used is it's USB-C for agents. So in this analogy, the computer is an agent like Cloud Desktop, and the tools are MCP servers, so the capabilities you want to instill or to give to that agent. That's it in a nutshell. There's a lot of detail then when you go into the spec. And Manuel, do you want to talk about local and remote MCP servers?
Yeah, and also maybe clients. So when we talk about MCP, probably people think, oh, but how can I interact with them? So nowadays the clients are many. Maybe the most popular ones are the ones that we can reach via our IDEs, like via Cursor, you can install and call MCP servers. Also, one popular option that you see across the internet is using the desktop app for Cloud. You can also configure MCP servers there and interact with them. And yeah, talking about local and server, local are nowadays the most popular ones. Most of them are only local, so it means that you actually need to run the code on your machine, configure the environment, and then connect to your client. And remote, as the name says, it's actually deployed by a provider, and you actually need to reach it and interact with it remotely. This opens maybe avenues for you to interact with more complex servers and also maybe authenticate yourself with accounts that you might have already there and remove the burden of you having to configure everything on your machine.
Okay, and still on that, because one thing that that at least feels lately is that MCP is super hyped. Like at least myself, I cannot go online without seeing MCP show up. So why is this so hyped lately? Like, what justifies the hype that MCP is having at this point? Would any of you like to start elaborating on
Yeah,
this?
yeah, I may start, and Jose, please complement anything that I might miss. So, first of all, I think it's like the mind-blowing potential that you can have. Like in a single client, let your LLM, your agent, interact with any set of tools that you want. If you imagine the combinatorial potential of any tools that you can have on your machine running, for instance, when it was launched, it was launched the protocol with already a couple of servers made in collaboration maybe with the people that launched the protocol, like Google Drive, Slack, GitHub. Only with 3 of these, you can imagine what you can do. And also maybe what is giving the hype is also the network effects that are coming from adoption. If you go to any marketplace that you see, you have plenty of servers that you can already interact with. The only limit now is your imagination and your creativity.
Yeah, let me try to complement that. I agree with everything. I think there's another angle to this. For companies that are building AI agents such as ourselves. And one thing that's clear, and I think there's not a lot of debate, is in the last 2.5 years, so we started looking into LLMs first, roughly around the time ChatGPT came out, so November 2022, thereabouts. And the progress in terms of not just the model capacity, but also their efficiency has been staggering in those 2.5 years. And this has sort of broad implications because the first systems we and the rest of the industry have started to build at the time, LLM chains, were sort of based on this idea where you take a complex problem, but then you need to break it down into very small problems in order to make them manageable for the current LLMs of the time to be able to do them. As we get better and better models that are cheaper, faster, and also more capable at things like following instructions or handling complex tasks, what we are seeing, or at least that's my opinion, and I think Manuel agrees, is that building the actual agents, much like the models, is getting commoditized. It's easier and easier to build an AI agent. It's really not that much of a differentiator. And if you now flip this around and think, like Manuel is saying, okay, if I have this general purpose agent like Cursor or Claude Desktop, which have been fine-tuned and tested in a variety of scenarios and optimized for the models that are being used, the range of tasks, of things you can do with the right set of tools is growing day by day. And I don't think there's an end in sight. That's the problem. I think if we try to think, and we need to do this right from a point of technological strategy, where do we need to be 12 months from now, 24 months from now? And we project, to me, it seems like the game is in how do you build tools? How do you share tools? How do you monetize the tools? So if you believe this, and you think about MCP being the first mover into this space as a standard, it's huge, right? It's not just from the end user perspective of, oh, this is nice. It's also, we now need to start thinking, okay, instead of just our agents, what does this mean? Because now, the IDE is a surface that's very premium because of these capabilities. Even with Raycast, we were talking the other day, it's a Mac Finder replacement. You can have MCP servers on there. Like, folks are finding places everywhere to use these sorts of agents.
I would also find that there is the point of view of also the user, how powerful this is for him, but also in terms of how it might change the paradigm, how software as a service do integrations. So, like, as exercise, imagine that nowadays in my IDE or in my Cloud Desktop app, I have 2 MCP servers. I have one for PagerDuty, and I have one for my Google Calendar. And if I want to check, okay, let's imagine that tomorrow I'm off, I'm on vacations, and I want to get someone to cover for me. Maybe I just need to call it to ask my Cursor or my ID, please cover me when I'm off, and it will be able to do that. Before this, it would be kind of different. Probably PagerDuty would have to build integration to Google Calendar. I would need to sign into PagerDuty, authorize the connection to Google Calendar for it to cross the data and to perform that action for me, even with an agent that is provided by PagerDuty. And this might accelerate and reduce the friction of creating integrations between different enterprises. And not only that, but also makes the user control how the data flows between providers. Because if before PagerDuty would have access to all my calendar, now I just give to PagerDuty the days when I'm off, and so you have more control on the data flows.
So if you could elaborate a bit on that part. So what you're telling me is, and if I understood this right, is you could have these two MCP servers that exist either locally or remotely, depending on how we are consuming them. And our client, so this client could be Claude, can be VS Code, can be anything that we use, any model, whatever, can basically interact with these two servers via calling their tools that are exposed via the servers, and then decide on the fly, okay, this tool, for instance, the PagerDuty needs tool for checking my on call needs certain days of availability, and depending on those days, it can figure out something on the server that if, okay, this person is going to be on call, this person is going to be on call. Is this basically what you're telling me, or is there like any nuance that I missed here?
Kind of. So it will understand to which server it needs to make a request for what, and relay only the result of that call to that server to the other server, only limiting and passing the minimum amount of information.
Okay.
And on top of that, you can also even control the model that you are using for all of these. Imagine if you are very strict about privacy and security, you might even use your own LLM for doing that.
Okay, that makes sense. There's a question that's already showing up here on the chat that I think we're going to approach in a bit, but I'm just going to acknowledge that Spencer is asking if there's an official PagerDuty MCP that you use. I'm gonna do the generic thing and tell Spencer wait for a couple of minutes, because we'll get into it just in a bit. But I want to circle back to something that José said earlier, because José said that we are building our own agents, and following up a bit on what this question, we're also building our own MCP server. So you as engineers have been doing this for a while, and well, the surprise that we're going to talk about here in a bit, you have spent some time developing PagerDuty's own MCP server. So I believe you learned a bit and quite a deal of stuff during this time. Could you share some of these lessons with me, some stuff that you learned throughout this time?
Yeah, I can start, and then I'll pass along to Manuel. Shall we put on some slides again? Maybe that could help. I think we have
Yes.
something.
Do you want to share your screen, or would it probably be easier?
Okay, I can. Let me see if I know how this works. I should share screen. Nope.
Manuel, are you able to do it? And then we'll
Wait, is it working?
It's already here. Yeah, it is. So you need to go to your slides now.
Okay.
Let's just
Alrighty.
And share screen. There we go. And I'm gonna add
fantastic.
slides. Let's see. It's gonna show up here in a bit. I need to remove this, and I need to add this. There we go. Logistics. But we have some slides now.
Yeah. So going back to what Manuel was saying, right? When you're building an MCP server for your company, or when we built ours, you're really building a set of capability that's going to live alongside other tools from potentially other vendors. And that's a lot of the power comes from there, right? You can combine different tools to do a certain specific flow. But unlike APIs, when we build APIs, we build them for human developers. We have endpoints, we have documentation, but they're not necessarily a good fit for agents for lots of reasons. But the key one I'm going to focus on is when you build an MCP server, it needs to be self-explanatory, meaning you need to be able to plug it in, and the agent needs to just understand how to use it. There can't be any sort of integration step. So really the first thing you need to do is you have the spec gives you two ways of doing this, which are the instructions that are almost like a system prompt, and the actual tool descriptions, right? So if you've built agents, you know what I'm talking about. If not, tools for agents, to simplify, and if you're a developer, think of them as functions, code that you can run to do a certain task. It could be running an action, getting some data. But the key difference here is when you're building the agents in the tools, you know how everything works, how it goes together. When you're building an MCP server, you're building for an unknown agent. You don't know the agent. So you really need to think carefully about these descriptions and how they're self-explanatory. That's kind of the first thing. And like I said, APIs were not built necessarily for agents. They're oftentimes too granular. There's a lot of endpoints. And if you simply created a tool for each endpoint, your agent would end up with hundreds of tools and not know what to do with them. And even if you ask the question like, hey, show me the instance for my teams, you need to go over a bunch of endpoints. Just, the agent would need to do a lot of work to figure that out. Manuel, do you want to talk a bit now, or should I continue?
The previous slide, only one thing that I would add is it needs to be self-explanatory. The instructions need to be very crafted. And once again, if you have developed agents, you know how tricky this is. But now imagine doing that without even knowing which LLM the user will use.
Yeah, exactly. So, do you want to talk briefly about this, or should I?
No, please continue. So you were talking about limiting the number not exposing as many APIs as you have.
Yeah, exactly. So one of the key problems today, at least, is that agents or LLMs, which are the brains of the agents, they will start to struggle if they have a lot of tools. And there's no set number where we say, oh, after this number, it stops working. It really depends. It also depends on, how similar the tools are. But, if we hand wave a little bit and just, look at it from a high level, generally speaking, the more tools you add to the agent, the more trouble an agent will have handling them. And here, this is what we see. This is from a LangChain article where they show a calendar scheduling agent, and some models like O1, which are more capable, can sort of maintain the performance, but you can see like GPT-4o, which is still a pretty good model, just nosedives immediately, and O3 Mini also consistently going down in terms of performance. So what you need to think about is, okay, if you have an API, you have hundreds of endpoints, how do you think about which endpoints or which tools to create to enable an agent you know nothing about? And the way we approach this, which is very similar to the way we approached building our own internal AI agents, is to start from the user journeys, to think, okay, conceivably, what questions do we expect, Claude Desktop or someone in VS Code Copilot with our MCP to be able to ask, and work backwards from there. So we separated our API into different domains, and we created what we call competency questions or capability questions. And then working backwards, what we do is we try to find the minimum number of tools that address the maximum number of questions. And that's the trade-off that you need to weigh. And also remember, your set of tools most likely will be living alongside other tools from other providers. So it's not like if I say, hey, you can have up to 100 tools, you can't just spend all the budget. You need to be friendly and let some budget for the other folks as well, because a lot of the potential, again, is maybe I want to use the GitHub MCP server and the PagerDuty MCP server in Slack so I can do my own workflows. Now, having said this, most, if not all, clients allow users to select the tools manually, so they could do that. But it's a lot more work. And me personally, when I use MCP servers, I appreciate that it can just plug them in and not have to spend time. And we also did an analysis of a lot of MCP servers from a lot of companies, and we saw that the number of tools per MCP server ranged from 1 to about 30 tops. So that's where we landed, about 26, I believe. And we split them into 14 read tools, and the rest is 12 write tools.
Mm-hmm.
Yeah, go ahead.
Could I ask a follow-up question on there? So you said that there's this maximum number that you saw average. Like, is this number somehow like something that we should stick to? Why is the reason why we should limit our tools? Is there any reason to that?
Yeah. So how does an agent or an LLM see the tools? How does it know how to use the tools? Behind the scenes, what is happening is each function, which basically, let's think of the tools as a function. each function or each tool is being translated into a JSON object that contains all the information needed to call it. The name, the description, the input types and names. So if you have hundreds and hundreds of tools, you will end up with a very big JSON, which will basically be a lot of context that you're adding to the LLM. Do you want to add anything, Manuel, here?
No, it's basically context. And as José said, so this is the number that we found that works well, and is a number that came up in our analysis of other MCP servers. But it does not mean that in 6 months LLMs cannot handle more tools. So it's something that we need to keep iterating, checking.
Okay, so in a short, just to say, so it's basically about making sure that the LLM is not overwhelmed in a sense of while going through everything. Okay.
Exactly that.
Okay, sorry, José, you were saying something exactly. I'm gonna let you continue.
Yeah, let's go on to the next thing we learned. Manuel, do you want to pick this one so it's not just me talking?
It's also what do you return? As José said, as you said, actually, it is not just going to our API spec and make a one-to-one match between a tool and the endpoint. And it's not only that, and it's also not only dumping what the API returns. So you might imagine the case where the user wants to know how many services my team has, and you can make that question in our API, passing some parameters. But actually what happens is it just dumps a very big JSON list. And as you might imagine, LLMs are not very good out of the box at filtering, making simple arithmetics and so on. So if you imagine that this is a common use case and a common path that your users might get into, it can be interesting for you to provide additional metadata on your responses that pre-craft is some basic analytics. Like here, for instance, we added this metadata saying that we return 112 records of type team. So this is also a lesson learned, so that we need to transform the outputs of our endpoints into something that the LMs can understand and reason from.
Yeah, exactly. So looking at the questions, right, the critical user journeys, thinking about how can we make it easy for an LLM to understand and perform those tasks that we've anticipated. And this pattern we've seen in other open source MCP servers, what we're showing here, that Manuel just described, of pre-computing this metadata to sort of almost like pre-processing the data in ways that are going to make it easier to use by the LLM. Another example, going back to the question, how many instances are there for my teams? If you simply had a tool for each of these, like, okay, a tool to get my information, a tool to get the teams, a tool to get the instance, each step to call a tool adds latency, so it slows down the experience, but also it adds the probability that the agent will make a mistake. Every step is non-deterministic, so there's a small chance that the agent will diverge. It will go off script, so to speak. Now, obviously, this is a very small tool chain call. It's only 3 tools. It's just for illustration. But another way to think of this would be, okay, I know we want to answer this question. So maybe what we can have, and again, we saw this pattern over and over again in other MCP servers, is to have an input field, for example, that's categorical, meaning the input can only be one of 3 values in this case, mine, teams, or all. And let the LLM, the agent, when calling the instance, say, okay, scope teams. It's much easier. It's a single call. It's more ergonomic. And then because the tool is just code, you already have the input parameter teams. You know, oh, it's for the team. So you know you need to call 3 different endpoints, aggregate that data and send it back. So less latency, less probability for mistakes. And potentially you can also have less tools if you mix and match this sort of capabilities. Okay, Manuel, I think this is probably the last thing. Well, we learned a lot more, but we're just sharing some, right? Otherwise, we'll be here all day.
Yes. Yeah, we actually needed to be creative on how to test all of this. So it's kind of a greenfield here. and not something that we could just look up the standards and replicate. So as I said before, this is a little bit different when you are building your agent, where you control the LLM, the version of LLM, the set of tools, all of that. So here you need to test first how it behaves in different LLMs, but also we also needed to come up with a way to structure our testing in a way that matches the way we structure our MCP server. And actually what we ended up doing was to create a set of test cases for each domain. And what we did is for each domain, we compiled a set of competency questions. And for each competency question, we tried to assert the tool selection done by the LLM. So I mean, for instance, in this example, if I ask the LLM to show me all the incidents, here I'm saying that I expect it to call the tool list incidents with a specific parameter. Same for the second example, show me all triggered incidents. I expect the specific tool to be called with these parameters. And we did this whole exercise for all the domains that we are exposing, try to do it, and then we run it across several LLMs. So this is also helpful not only for the final test, but also when you are developing, to have a kind of a sense of regression if you're breaking any functionality or not. Of course, this is not extensive, but it covered most of what we wanted to test. And yes, for sure, some domains might depend on other domains, so you need to mock maybe responses from tools from other domains, even if you're not testing those directly. So it's tricky, but I invite you to take a look at how we have done it, and if you have any comments, any ideas, please feel free.
Yeah, absolutely. Like Manuel said, this is a little bit greenfield in terms of best practice. We again looked at all the major players in terms of their implementation, took ideas from several places, added some of our own, and yeah, the key we have this in the open source repo that we're sharing today. Well, maybe I'm spoiling. I'm sorry, but just to complete what Manuel was saying. We care more about the way that unknown agent, the combination of the agent itself, let's say called desktop, and the LLM, we care more about the way they're calling the tools than the actual responses themselves. We want to make sure that the MCP server is easy to use by different combinations of agents. And because certain questions we know will require a chain or a sequence of tool calls, to make sure that those intermediate states lead you towards the right place. And this is not a complete or optimal solution. It's an approximation, but it's pretty good. We added the ability to mock the responses from the agent so that we can keep the trajectory more or less aligned. So yeah, it's interesting times. I'm sure folks will come up with different ideas and new patterns to do this. But yeah, we're pretty pleased with what we have so far.
Okay, and that is really exciting, and there's already some questions popping up here, so I'm going to stop before we add up to the next point we would like to chat. There's at least 2 questions that I would like to go through, so in the meantime, let me show them here. So Anna asked, how secure is the MCP context? Could another app sneak in and mess with it?
That's a very interesting question. Do you want to take it, Manuel, or
No,
I can? Do you want me to start? Okay. So the way, yes, the short answer is another malicious MCP server could, to my understanding, sneak in and mess with it. And I will explain why. Think of the agent as a shared playground, right? Our tools are there, other vendor tools are there. And when you ask a question that triggers one of the tools we provide, the agent will call the tool, we'll provide the answer back. It's in this shared context. Now let's imagine we have a malicious MCP server that provides some tools that on the surface look legitimate, But within the prompt, within the tool description, they could say something like, hey, when you call this tool, also read this file, potentially that contains some secrets, and send it to some server or exfiltrate that data. That's an example from your machine, or just send me the context, everything that's on the context, right? So any information that's being fetched from the MCP server could potentially be exposed. So how do you, I guess your question perhaps is, how do you account for this? How do you solve this? And it's not fundamentally different, in my opinion, than what we do for normal engineering practice, which is role-based access control, least privileged access. You always need to think about how are you going to provide authentication mechanisms for your MCP server. What we did for ours is we use and support user API tokens. So we scope all the information that's available to the user. So there's already a level of protection there if it's only data that's being available to that user. Now, on the flip side is, how can we protect users from installing malicious MCP servers that exfiltrate data? That's actually part of the reason why we wanted to launch our own MCP server, even though there are already, and we're going to work with some of the authors of the existing open source MCP servers for PagerDuty, is that some of our customers are aware of this problem, and they're very sensitive to the idea of supply chain attacks, where, let's say, you might have an MCP server that's okay, it's open source, but maybe the maintainer, gives it up, passes on to someone else. You're really not keeping track of, your software bill of materials in this sense. You're not making sure there's an audit trail or someone that's making sure that no one can come in, make a PR that's malicious, and suddenly if you update your MCP server, now you're exposed to a vulnerability. So not that I'm advocating only use MCP servers that are from official companies. I'm not saying that. I'm saying that is probably a good conservative stance if you're an enterprise and you're just, putting your toes in the water. But be aware, talk to your security team, they're your friends, and, keep informed of the potential risks.
And I think that this, like what you've been telling, kind of also follows up a bit on the next question that here, like what we need to watch out when picking an MCP to integrate with an agent. So I would say, like, you already answered a bit of this question. Is there anything that comes to mind that you didn't talk before that might be relevant for this question here?
Well, there's a lot of attention right now. I'll be honest, I'm not a security expert, so I don't know all of the mechanisms and resources to do this. But there are lists and entities that keep track of vulnerabilities and publish them. Just recently, from our own security team, I got a message about yet another vulnerability in an MCP server. So I think it's a team sport, and there's a lot of attention, and a lot of folks are paying attention. So if you're in a company, make sure your security team is well informed about the potential risks. There's plenty of articles about this. In fact, there was one making the rounds a while ago that the title was "The S in MCP stands for security." And it was partly a jest that, this is not very secure. And it can be. Folks just need to be informed, and especially these local MCP servers, you need to be very careful that you are sure of the provenance of the MCP server before you use them. Are they from a reputable company? How many GitHub stars do they have? Have you looked at the code if you're a developer and you can inspect it? It's a different story for remote MCP servers, and that would be a whole different can of worms about OAuth. So unless there's a lot of appetite to go down that route, we can probably go to something else.
Okay, yes. So I was gonna talk a bit about that part as well. Like, we were talking about the discovery of MCP servers and like how do we figure out the official ones, like versus third party, whatever. There's I would say a very good resource there. Like Anthropic put out on their Model Context Protocol GitHub like an official list of servers that anyone can check at any time and contribute to. So I'm gonna paste this link on the chat so that everyone could check it. It'll also be on the resource notes that we are going to post at the end. So I'm sending it right now for the chat in case you want to check it out. But well, we've been talking about this for a bit, so I think it's time we say it already. Like, PagerDuty MCP server is live. It's live. We're also going to be pasting it here on the chat so everyone can check it. I think that, well, seeing is believing, so we have something that's live. Anyone wants to share a bit of this MCP server working?
Yeah, we have some examples. Do you want me to share, Manuel, and you voice over?
Feel free to share. Actually, it was you recording those, so probably it's easier for you.
Yeah, I'm trying to. I had this open, but computers. All right. I think we can probably. Really? Oh, Murphy.
It's the access, when it's
It's fine.
it always
got
is something, but it's gonna work out. We already managed to get it working.
Exactly.
If you are not able to make it play, I can share slides with the video. José.
Okay, it seems to be showing up here for me.
I think I got it.
Okay, so I'm gonna let José start playing, and I'm gonna add this to the stage. I need to remove this one. Sorry, as well, figuring out stuff. Let's do it. Okay.
Let's see if this works. Actually. Oh no. No.
You stopped seeing it?
It's the resolution is terrible. Apologies. Okay. Let me try again.
Let's wait for a bit. In the meantime, whilst we're talking, feel free to check out the MCP server that we pasted on the chat. And there we go.
Yeah, can you see my screen? This is a GIF, so it's going to loop, but hopefully at least we can read it.
Yes, we're showing the latest incident. That's what we're seeing.
Yeah. Here. So this is a very simple, very simple scenario. And like we were talking at the beginning, right? We need to rethink the user experience and who the target audience is. We're developers. We spend a lot of time in the editor, and let's imagine there's a problem. Someone's complaining, hey, we have an ongoing incident. You don't even need to leave your editor. This is all in VS Code with Copilot. So for those of you that have not used Copilot, or if you've used and not used agent mode, on the bottom left, you have this drop down here. Typically, it's in Ask by default, I believe. You can change it to agent. And when you change it to agent, on the right, can you see my mouse cursor, or am I... Can you, Daniel, see my mouse cursor?
No, I don't see it at least.
Okay. On the bottom right, you have the tools symbol where you can add MCP servers. So yeah, without leaving the editor, you can just ask questions about instance. That's just a very simple example. Show me my team's instance, like we talked about before as an example. Single tool call gives you all the instance for your teams. And now if you scroll up and open and see exactly what's going on, you can see that request scope and the team. So that ergonomic feature that we talked about before in action. Let's see what we have more. Okay, this is more of the same, I believe. Okay, let's say you noticed something is wrong and you want to create an incident. The good thing about agentic flows is, for example, at PD, if you create an incident, by default, it's going to be assigned to whoever is on call. But let's say you actually want to also immediately reassign that. You can say something like create an incident, give it the name, and assign it to myself in this case. And maybe it doesn't seem like it, but there's a lot going on under the hood. So the first thing is the agent is figuring out who the user is. It calls it the tool two times because it had trouble with my name, because my name has a dash between my surname is impronounceable in English, so apologies. But it tries like this, and then it just tries with José, finds all the José, and picks the right one by approximation, and then lists the services and creates the incident. You also notice here that when it creates the incident, it shows you a pop-up. When you're building tools in MCP, you can give a hint to say, hey, this is a right tool. And the clients can use that information to ask the user first before actually playing the action. As a user, you can very much click on the arrow next to continue and say always allow if you like to live on the fast lane. And finally, it's using the manage instance tool that is multi-purpose. It can be used to acknowledge instance, resolve instance, and also reassign instance. So all this is happening in a single sentence. You can even go crazier. You can do things like, I don't know, create an incident, problem with the payments database, add a note, add José as a responder. So different thing. Oh, and also, because I'm saying the title, it's payments database, it also infers automatically which service it is because we have a payment service. Obviously, performance will vary. If you have very similar sounding services and you're trying to do this, it pays off to be as explicit as possible to an agent. Don't try to make its life harder than it needs to be. But very much if things are lined up and you have well-named services that are different semantically, yes, agents are very flexible and can do a lot of things. What else do we have? Manuel, do you want to? Oh, this is interesting. We're going into the on-call.
Yeah.
Do you want to?
No.
Okay.
This is similar user journey that I described earlier when I was saying the example of the marketplace.
No, this is before. This is just, am I on call tomorrow? So this is just, on call is a sensitive topic for developers. So, making sure you can understand, okay, am I on call tomorrow? Am I on call on Wednesday between 3 and 4 p.m.? Or more specifically, and this is the example that Manuel was talking about before, and also showcases the potential of MCP. Do I have any on-call conflicts tomorrow? Here you can combine, for example, our MCP with Google's, and it can say, oh, actually, yes, you do have something on your calendar tomorrow, and you're on call. So maybe there's a problem. So this is where I think both of us believe, where the magic starts to happen, right? And it's very hard for us, even when we're building our own internal agents, to anticipate all of the potential combinations, all the corner cases, all of the different potential that folks will be able or want to do with agents and MCP servers.
Yeah.
And there's...
I think this example shows how powerful this is. Actually, for instance, imagine that we only support Google Calendar at PagerDuty, but a very interesting client that really loves PagerDuty is deciding to churn because they move to no-show calendar, for instance. This will allow them to work without having us to make a single code of line in PagerDuty. So
yeah, exactly. Okay, let me go back to... Was that good enough, Daniel? I think that's all we had in terms of...
Yeah, that was
not enough? Okay.
Well, we have people saying it's interesting, so people are excited about it. Thanks, Anna. One question. So what we saw happening here, like you mentioned this briefly, José, but I think it's like from the brief context, like what's happening underneath, like for each of those GIFs, those videos, like there was a call for these tools that was happening. Because basically the model was inferring, okay, for this context, I need to use this tool. It calls the tool. But one thing that you mentioned very briefly was that you had allowed all these tools to be called automatically. I think one thing it's important to mention here is that you, as the person who's using the MCP, you have the control to decide if you're going to let the model or the agent call this specific tool. So if you trust an agent, a server, you can also tell it, okay, accept all the tools from here. You can always call them. You have full control, or you can be more granular and say, okay, this time accept this specific tool.
Yes.
So it's, I think the part of control, it's very important that we put it out there so that people know, okay, exactly, we can control the tools that we give access of the servers that we are using.
Exactly. And that's typically defined by the clients, or in this case, Copilot. And they're more or less all of them follow the same semantics, which is always allow for this session, and you can do it tool by tool. For example, I would probably not recommend doing this for the create incident tool unless you really don't like your on-call colleagues, especially if they're in a different time zone. That would be, crazy.
That's already a good tip that for people using our MCP server, like feel free to accept all the other ones, but the ones that you would see triggering some cases where people might be disturbed by that tool being called, make sure to have them on a control basis. Okay, so we have a couple of minutes still prior to ending this session. So far, we have been discussing about present. We've been talking about lessons that we learned. Now we shared about our MCP server, which is live, and you have been working on it. So let's turn our sights now to the future for these last 12, 10 minutes that we have for the live stream. Where do you see MCP going? So where's the future in this? Because so far there's so much hype, and it's so much hype for something that was released in November. I think that this is also some important to note. Like, this standard was released by Anthropic in November, so we've just started hearing about this a couple of months ago, which in the world of AI seems like we are always following up. But from your perspective, where is MCP going? So what are the things that you're excited about? What are the things that you see as going up on the future?
Yeah. Do you want to start, Manuel? Or
For me, it's actually I would like to see more remote MCP servers, because nowadays it's not very accessible to everyone to actually configure and use all of those. And also what it means and what unlocks to have remote MCP servers, even in terms of integration between several companies. Also, what unlocks in terms of agent communication between different enterprises. There is a lot of potential there. As I said before, most of MCP servers for now are only local, but I expect that to change very soon as everyone agrees on a standard. I also feel that there is still some way to go on the clients that we have nowadays. So we have this very generic one called desktop, but even so today is hard to configure and debug. You need to be tech savvy, let's say, to use it. And then on the other side, you have ones that are very crafted for developers, like inside the IDEs, and maybe for developers it's easy to configure. But we are lacking one for other type of profiles and roles, and also maybe there is also some uncertainty on the kind of surfaces that you have, because until now the browser was king, right? Everything was based on the UI. There is some exciting work going on the surfaces, like trying to reshape how browser work. Like I saw the other day, the browser launched by the browser is called Dia browser. It's from the same makers of the Arc browser, and also saw the one from Perplexity. They are trying to adapt the browser to these modern times. Maybe I think the next step will also be to include MCP servers in these browsers to make it even more powerful. And maybe that can be the way for regular people, not only developers, to start accessing this technology. Yeah. José, do you want to add anything?
yeah, I have I think a complementary take on this. So we have a sort of three-phased approach at PagerDuty with MCP. We started with a local MCP server, and the reason we started there is, like Manuel I think said before, the vast majority of MCP servers that exist today are local MCP servers. So that means you need to download them, run them on your machine. This was sort of the initial use case. It's an augmentation to local clients. The standard has evolved, and one of the things it brought was, like we said, remote MCP servers. We see this as a huge potential unlock. The reason is simple. We also alluded to this briefly before, which is lowering the cost of integrations between companies. Today, we have 700 plus integrations. We're very much API first, but still we have what we call first-party integrations, ones that we were more bespoke or seamless experience, or we don't want to rely on a third party to build it, so we build them ourselves. When we now project this to the agent world, where we have agents working on our platform, the sheer potential of tapping into this ecosystem of MCP servers is huge. What's the problem? The first problem is local MCP servers, because they're local, and like we said, you need to authenticate somehow. Typically what you do is you run the server and you pass in as an environment variable or a configuration file your API token. So they are, for the most part, fundamentally single tenant. So if you have a system like ours, a platform that's multi-tenant, we have an agent that's receiving, a lot of requests from different customers. We need to have, if we want to have a set of tools, sort of an internal marketplace of external tools, that doesn't really work very well. And it's an interesting problem. Folks are talking about it in the industry. There's a very interesting thread. I'm not sure if we have this in the talk notes at the end, because I know I sent this to you, Danielle, where folks are discussing how to solve this sort of problems. Cloudflare came up with an ingenious solution with their durable objects, where they essentially spin up an MCP on demand for each customer request, which is not something we're really excited to do, at least in the short term. What I see is, as we move into the remote MCP servers, they're remote. You need to connect over the internet, over HTTP. So the authentication mechanism is OAuth, and they are natively multi-tenant. So for us to be able to tap into this collective investment, this is a huge opportunity we see. And not just to have tools to have our agents call and augment them. And we're still working out what the best model is in terms of UX, in terms of product, in terms of technology. So I'm not saying exactly how it's going to work, but we're working on it. The other part is tools can be agents, right? You can have an agent and another agent on the other end, and this already exists. We have used recently Glean's MCP server. Glean, for those of you who don't know, it's almost a RAG-like. It's more than RAG. I don't want to downplay it, but it's an agent that can answer questions about documents, and it has a lot of capability as a single tool, chat, right? So you're sending natural text, you're getting natural text back. We know, and we're also looking into other standards like A2A. But right now, we see a lot of potential and are working on this new wave, the second phase of the remote MCP server, and potentially third phase. Second phase, is we build our own remote MCP server, and third phase would be we start looking at how we can leverage remote MCP servers from third parties in our product.
You said a word there. Could you just define for people watching what A2A is?
Oh, sorry, you're right. So this is Google's standard for agent-to-agent communication. And the way it's been presented to the industry has been as sort of a complement to MCP. So whereas MCP is used for tool calling and sort of more localized interactions, A2A is used to coordinate, for example, a mesh, peer-to-peer architectures of agents with long-running tasks and complex, flows of work and data.
Okay, thanks for that, Manuel. Do you want to add something?
Just something that came up to my mind is also I'm kind of optimistic how this can shape the market and how innovation can benefit from this technology. So if you imagine that when you need to start a new software as a service or a new company, a new startup, let's say, a huge chunk of the work would be to actually create the interface that users could use. And now everything is free in that sense. There is also there is already a universal interface that is the LLMs that users can provide. So on your end, you just actually need to provide the functionality. So you can really focus on the core business and be very nimble on your development and actually start providing value to your clients. And not only for new enterprises, but also in terms of disruption of existing markets. New competition may arise very quickly if you're leveraging this new surface. So let's see what happens. But I'm quite optimistic.
Yeah. That's a great point, right? Even if you're a startup and you're already like just working on Slack, or you're very targeted, you have a niche, you still have to do that integration work. You still have to, there's always something. Here it's almost like an API, but you get the benefit of these very powerful front ends, essentially. Food for thought, yeah.
Yeah, so it's a sea of possibilities. It's what we are seeing here, basically. Okay, so I feel like we're running out of time, so I think we can call it for today. Before we wrap up, I just want to share some things. Like I want to thank everyone that joined. Like we were having some comments while Jose was explaining a bit what agent to agent was happening and some more stuff. So thanks for that. Uh, some folks showed up as well. I just saw Vinicius drop into the chat as well. I think he's also been building some MCP servers. And some stuff. I'm interested to see the stuff that you've been building there. So everyone, because this has been streamed throughout LinkedIn, throughout Twitch, throughout YouTube, we are trying to find a way that you can get access to all the resources that we have chatted through today. So we are asking you, if you're not there on PagerDuty Commons, to join PagerDuty Commons. We're gonna post a bit of the resources that we talked throughout this session. So Jose and Manuel will share them with me. I know there's some other stuff that everyone's very excited to read to. Our links are going to be there as well. And just some heads up. So next week we're gonna have a webinar which is going to focus on the state of AI and incident management. I think we might have some people talk about MCP there. Well, perhaps. Well, we'll see where MCP stands on this discussion. So, and the final one, we already went through it as well. Our MCP server is live. So check it out, give it a star. Play with it. If you have questions, please ask them there. If you have anything that you would like to get an answer to, in a sense, let's call it that way, feel free to open an issue as well on the repository. I don't know if Jose Manuel, if you want to have any parting message that you would like to share with everyone.
No, just we're excited. Any feedback, greatly appreciated. Happy to collaborate with the open source community. Like I said, we are already talking to one of the authors of another open source PagerDuty MCP server. Very much want to build this out in the open. So yeah, excited to work on this. Join in.
On my side, thank you for inviting me to be here. It was a pleasure. And as Jose said, please download it, try to use it, give us feedback, and let's see how MCP evolves from now on.
Exactly. So everyone, thank you so much for joining. Let's hope that we have another of these ones very soon, and we bring Jose and Manuel back to talk about other stuff. We'll see. Maybe continue talking about MCP. Like, I feel like we could have continued this stream for another 30-40 minutes on just agents and other stuff that we could go through. So thanks to Jose, thanks to Manuel for being here. Everyone, thank you for joining. This will be available on YouTube. It will be available on LinkedIn. So if you want to rewatch, if you want to continue the discussion, one thing I forgot to mention as well, on the link that we shared on PT Commons, you can ask follow-up questions that we'll share with Jose and Manuel, and maybe they'll even answer you there on PT Commons. So if you have other follow-up questions, feel free to drop by. So everyone, we'll see you on the next week for our demo roundup. And that's it. Thanks, everyone. Bye.
Bye.